Hi, this is Chris, and we are diving into the grid-in questions in Section 4 of SAT Practice Test 1. So, as we might have seen in Section 3, when you get to the grid-in questions, you don't have the answer choices that you can use to your advantage to try to work backwards through a question. So, sometimes people find this more difficult, but just keep in mind, in terms of order of difficulty, the good news about the grid-ins is that the difficulty resets. So, this, in theory, should be a relatively easy question on 31, and as you progress up through question 38, by the time we get to 38, this one should be pretty tough when we get there. But the reason that's important to note is the multiple choice goes easy to hard as well. So if you get stuck towards the end of the multiple choice because you're facing some tough questions, you don't want to get caught there and spend too much time on those tough ones and maybe leave a couple of these easier ones in the grid-ins unanswered. So as much as students don't always love the grid-in section, just keep in mind that you do want to take advantage of at least the reduction in difficulty level when you move from the multiple choice into the beginning parts of the grid-ins. So here, let's take a look at question 31 itself. It says, Wyatt can husk at least 12 dozen ears of corn per hour and at most 18 dozen ears of corn per hour. Based on this information, what is a possible amount of time in hours that it could take Wyatt to husk 72 dozen ears of corn? Okay, so if you're given a range of potential values, like in this case, at least 12 and at most 18, so at least 12 dozen, at most 18 dozen. When you see that range of values, the best mindset in terms of how to approach those questions is to treat it as if it's two separate questions. You're going to solve the question once to figure out what your result would be for the lower end of that range, and then you're going to solve it again to figure out what your result would be by using the number at the higher end of that range. So instead of trying to find a value somewhere in the middle where maybe the math isn't going to work out as smoothly as you want it to, treat it like it's two separate questions. We're going to solve this question thinking that Wyatt can husk 12 dozen ears of corn. We're going to solve it again looking at Wyatt husking 18 dozen ears of corn, and we're going to see what our answers are for each. And then our correct answer will be something that falls within that range of solutions. Let's take a look at how this works. So here, they want to know a possible amount of time in hours that it could take Wyatt to husk 72 dozen ears of corn. So let's start with 72 dozen total divided by 12 per hour. That'll give us a total of 6 hours that it would take at 12 dozen ears of corn per hour. So at the low end of his husking speed here. And then at the high end, if we have 72 total dozen ears of corn divided by 18 dozen per hour, that would be 4 hours, which kind of makes sense if you think about the general relationship between time and rate. In this case, with 18, he's working a little bit faster, so it's going to take a little bit less time. It only takes 4 hours to get those 72 dozen ears of corn husked. If he is working a little bit slower, then the time's going to be a little bit higher. It takes longer if you're moving a little bit slower. But that's going to be our range. And so when they say what is a possible amount of time in hours, we can pick anything from 4 to 6. So if you want to be safe and go right in the middle, you can pick 5. You could pick 4. You could pick 6. This particular question is inclusive. You do want to be careful about that. But any of those answer choices that you bubble in within that range from 4 to 6 will be correct on 31. Now for 32. Let's take a look here. It says the posted weight limit for a covered wooden bridge in Pennsylvania is 6,000 pounds. A delivery truck that is carrying X identical boxes, each weighing 14 pounds, will pass over the bridge. If the combined weight of the empty delivery truck and its driver is 4,500 pounds, what's the maximum possible value for X that will keep the combined weight of the truck, driver, and boxes below the bridge's posted weight limit? So, this is a lengthy word problem, and they're asking us to create an equation, or in this case, an inequality from this information. So let's see what the total weight of the truck is going to be. They give us a constant value here, 4,500 pounds, and that's going to be for the truck and the driver. So that's our constant. It's going to be 4,500. and then plus the boxes. And here we have X identical boxes, and they are 14 pounds each. So that would be 14 times however many boxes there are times X. That would give us our total weight of the truck, the driver, plus the boxes. And then here, what's important to note is that they want to know the maximum possible value for X. And it says that we'll keep the combined weight of the truck driver and boxes below the bridge's posted weight limit, which means it can't be equal to the bridge's posted weight limit. It has to be below this value of 6,000. So just keep in mind, whenever you're reading a word problem, it's very important to note whether something is going to be inclusive of a certain value or exclusive, if it's going to be greater than or equal to versus just greater than, or in this case, less than instead of less than or equal to. I see a lot of students on this problem, they set it up correctly for these two parts, but then they put an equal sign here and try to solve and try to bubble in an answer choice that they get when solving the equals equation instead of the less than inequality. And let's take a look at why that could be trouble. Because if we actually do the math here, what we come up with is you subtract 4,500 from both sides. So you get 14x is less than 1,500. And then if you divide 1,500 by 14, it comes out to be a decimal. You'll get x is less than 107.14. So a lot of times, if students put an equal sign there instead of less than, they try to bubble in 107 and then maybe part of the decimal, and they're not sure how to round. There's not enough spaces to fit the decimal in there. They get stuck. They think maybe something went wrong in the problem. They go to recalculate. So it leads you into a wide array of trouble if we don't interpret the inequality aspect of the question when reading the word problem carefully. If we do have less than, then it makes it a little bit easier, because here they're asking for the maximum possible value for x. And x is a number of identical boxes. So we want to understand the context of the word problem here. You can't have 107.14 boxes. For us to remain less than 107.14, the maximum possible value that is less than that is going to be 107. And if we understand the context of the question and set up the inequality properly, then we can bubble in 107 a little bit more confidently here. Now let's take a look at 33. So here we see this graph showing the number of portable media players sold worldwide each year from 2006 to 2011. And our question reads, according to the line graph above, the number of portable media players sold in 2008 is what fraction of the number sold in 2011. So this is really data interpretation skills being tested a little bit more than your actual math skills. They want to see that you can read this graph properly. So we look for 2008, and that number is 100 even. And it says what fraction of. Remember when they say of, when you're talking about fractions, so is over of, or part over whole. Your of portion of your fraction is going to be your denominator. So if you're not sure how to interpret that, just look for that keyword of. When you're talking about fractions, of lets you know that that's the piece that's going to be in your denominator. So 2011 will be our denominator here. We find that on the graph. That's a value of 160. And we have 100 over 160 as our fraction. Now, if you were to try to grid that in, then what you'll notice is that that's not going to work, because as we see in the sample instructions above, which you should get very comfortable with even prior to the test, but you only have these 4 spots. And yes, you can grid in fractions or decimal values, but there's only a total of 4 spaces available. And if you try to grid in 100 with a slash and then 160, that would be a total of 7 spaces required. So just make sure with fractions on gridding questions, you do need to reduce, oftentimes just to be able to fit it in the space provided. So here we could eliminate a 0 or divide both of them by 10. This would be 10 over 16. And we can still reduce that a little bit further. Those are both divisible by 2. So the fully reduced version of this fraction is 5 over 8. All right, let's take a look at the last one on this page, which is question 34. And it reads, a local television station sells time slots for programs in 30-minute intervals. If the station operates 24 hours per day, every day of the week, what is the total number of 30-minute time slots the station can sell for Tuesday and Wednesday? So a lot of times on this question, I see students dive in and they want to start doing calculations a little bit too soon because they read this as every day of the week, and so they want to account for 24 hours per day for 7 days. But be careful. Make sure that you actually read the question in its entirety to understand what you're really solving for, because here they just want to know the total for Tuesday and Wednesday, only 2 days. So 2 days times 24 hours a day, that would be a total of 48 hours of time slots. And if they're sold in 30-minute intervals, that means that there are 2 time slots per hour. So if you double that value, 48 times 2 will give us 96, and that's the number of total time slots available in those half-hour increments across that 2-day period. Up next, we'll take a look at the rest of our grid-in questions.